Next up, a guy you may not know, but he knows all about you because he controls pretty much all of the routers out there. So careful with this guy. I would wisecrack something funny about him, but he's much stronger and bulkier looking than me. I don't really know him, so you know I might get my ass kicked. So I'll just skip that. But he not only does he do you know, consumer stuff. My understanding is when Pope comes to town, this guy is called to do the Wi-Fi. Is that right? Please welcome Ravi Gundu.
Hello, are you able to hear me properly? So, good morning everyone. So, let me start with this. You might find this, oh, what is it all about? Don't let me down. So, one day, I saw an email from CWNP saying that, oh, Ravi, you said you were going to present this year. So, what are you going to present? So, on a Saturday, after having my breakfast, I sit and I think about a topic. First thing that pops up on my laptop is a notification that something screwed up in the network, right? The next minute, I hear Pandora playing me Chainsmokers, Don't Let Me Down. That's how this happened. Okay, so moving on to the presentation, right? How do I go back? Yeah. So I started with Comcast 6 years back, and I was in different capacities. I was doing all the devices, different kinds of Wi-Fi, DOCSIS, fiber, backhauls, everything. Then I was moved to this interesting project called Xfinity WiFi, where I'm consulting with all the vendors, all the stakeholders to see what they expect and what we can build. Right, so in this phase, we felt that, okay, there are a lot of statements that are thrown out there, like, okay, so tomorrow I want to deploy Wi-Fi somewhere, right? I have to see what I have on the table. So when I go and talk to the vendors, they say, oh, we have this product that does gigs, gigs, gigs. And we have dual 5 gig radios, we have tri-radio AP, we have an 8x8 support, and then we also have a multi-gig port to be able to support your Wave 2 or AX speeds. And based on that, I go back to my management with an input saying that, okay, these are the product offerings. Now, I talk to the customers, and I talk to everyone in the lineup, right? They say, okay, you have all this. Can I get a gig everywhere? And I don't know if somebody has done a design where you support gig speeds everywhere across the venue. Did anyone do that already? Okay. And the same thing gets advertised from our PRs too, right? So we say the fastest Wi-Fi in town, or the fastest Wi-Fi is here across the venue. So let's get to that. Now we get into the reality now, where, okay, as a Wi-Fi engineer, what do I design? Have the product that supports gig speeds. I have the network that's capable of doing everything. So now if I go to a venue, how many APs should I put? And how many customers do I expect? And what kind of traffic do I expect? All these things form the crux of the design, right? So now, when I have to choose one access point over the other, what do I look at? First thing is the spec sheet. Second thing is the lineup of features that they have. And third thing is the support, right? Now, if I have to see how this access point performs under a set of unique conditions, do I have access to test data? Maybe, but in most cases, that is missing. So in 2013, we have decided that, yes, we need to build a catalog where we have a set of repeatable tests that address every unique situation, right? So that was our first attempt. We invested in Ixia VeriWave, and we started doing some baselining across all the APs that we have. and all the APIs that we are going to deploy in the future. So now we are baselining these things, and we are good. Then in 2015, we sat back and we were like, OK, we see some issues from the field. And what is the nature of the issue? And how can we make sure that we test all of them and make necessary recommendations to resolve these bugs or any of these issues? So that's when we have started looking at, OK, what kind of client mix do I throw in? What kind of environments do I deploy this AP in? And what kind of radios and what kind of configuration do I have to use this AP with? So that has actually started us going towards a much bigger and a much exhaustive lab where you can probably test every aspect. Right? So in this presentation, I would like to present some kind of these tests where you can apply the design practices. Maybe it's from the site survey, maybe it's from your on-field packet captures, or maybe it's from your configuration or experience perspective, right? And secondly, what kind of a test bed would suit your needs, right? So this is my test classification as a whole. So the first part is we get an AP, we just benchmark it. We say, OK, it's capable of supporting this much throughput, this much clients, and then under some conditions, we have this packet loss and this latency, right? And we start comparing an AP1 from a vendor to an AP2 from another vendor, right? And then, so one question, how many of you have deployed the APs in an environment with their default configurations? I hope no one, right? At least we would tune the transmit power down, right? That's one thing. So now AP has its core performance, but now when I configure different things on this AP, how is it going to react? Is it going to meet my expectations, or is it going to be vulnerable, right? That's the second slice of it. And third thing, we have got everything right. We configured the AP. We have decided what AP we are going to do it. Now, if I go and if I see, OK, I have baselined it against 3x3 clients. I see the best throughput. But is my environment going to see these kind of clients? Might not. Secondly, will the AP perform the same way when it sees the duty cycle on the channel, I mean, the utilization? And also, how does it react to noise? Because some vendors have promised me that they are immune to noise. Like they have features for adaptive noise immunity. They have features to avoid or back off on certain channels. And we have to test how efficient they are and what comes out of it when they are actually acting on all these things. Then, since we are talking about a network, we have to even talk about how the necessary handoffs happen. For example, if I get a tri-radio AP where somebody promises me, yeah, you have to, if you keep your private network on one of the radios and the public network on the other, you are just good. And somebody says, you should probably have both these on both the radios because it will help you to be efficient with your load balancing. So how efficient or how good the AP or this feature is doing for me in the network. So this is the high-level classification. So let's go to the baseline test. So what happens in the baseline test, right? So we take a set of parameters, and we see how the top 5 KPIs perform, like the latency, how many clients can the AP handle, how is the throughput, how is the forwarding rate, and how is the packet loss under each of these conditions. And to specify these parameters on a high level, we have distributions across packet sizes. We have distributions across channel width, 20, 40, 80, 160. And we have different MCS that the clients connected. And then we have also the spatial streams, right? So if we go back and see our network today, right, 50 to 60% of the clients today in this world are probably 2x2 connecting to a network. And that's what our data says when we ask our partners to send us, right? And then, so there have been cases where the APs are doing very good with downstream traffic. But when we talk about upstream, sometimes, yes, sometimes they are probably only 10% efficient, maybe because of the algorithms that they use, right? So we have decided that we should invest in a vendor for us to be able to test across all these things, and some of these are already predefined. Most of the vendors actually have predefined tests for the baselining. So this is our typical test bed where we have an isolation chamber where the AP goes into, and then from the AP, we have a Ethernet connection and a Wi-Fi connection to the traffic generator. And what the traffic generator gives is the number of packets sent, the rate at which the packet is sent, and the rate at which it is received, and what all conditions it saw. And between the generator and the analyzer, we have a programmable attenuator that actually helps us reduce the signal coming from the AP to the client and vice versa. So for example, say a client connected at NEC 45 or NEC 50 RSSI to an AP. And the AP also sees the client at the same level, right? So what happens with respect to throughput? It's technically in best of the conditions because it's in a chamber, and it would probably give you the best speeds. Now, if I increase the attenuation between these things, and I suddenly see my client at NEC 70, how does it perform? I don't know. It might be the same, or it might degrade. So these are the baselining parameters that I have always put into the baselining mix. So packet sizes. We have data from our network saying that some part of the network has a very small packet size going through. And we also have channel sweep saying that, OK, the AP performs best on one channel, and it performs a little bad or worse in another channel. And then, as I discussed earlier, we throw these client characteristics. We throw all these things into the mix. So how do I configure these, right? So this is a typical screenshot where you could see that there is a facility to me to specify the number of spatial streams that I want to use, the signaling bandwidth, the MCS index, then the management fire rates, then the guard interval, then whatnot. We have everything that we can. And when you actually test, right? So the screenshot on the left, on the right side actually says what you want the conditions of the test to be. Do you want it to run for 30 minutes? Do you want it to run for an hour? Do you want it to run for a day? And what kind of loss do you actually allow when you're saying I'm baselining? And how long do you want how much interval do you want to give between your tests? So all these parameters right on the screenshot for you. And then this is a typical throughput report that I ran. So this is from one of the APIs that we have. So if you see the x-axis, we have the packet sizes. If we see the y-axis, we have the throughput rate achieved. So this is with 10 clients. And we can definitely say that if you have smaller packets on the network, your throughput is probably half. So once we have established a baseline on the AP, right? Now we should focus on what does it mean to the experience for the client device, right? So peak numbers is always good to have. For example, I say 1.5 gig throughput on my AP. That's good. But how does it reflect on the customer's device is the first question. So in this case, we would say we create a mix of different client types, different traffic types, and different test types, right? So there are two kinds of tests that we do here. One is a static test where we predefine all our clients. The thing runs for some time and generates as a report. And these can be used for comparisons on how our network has evolved. Second thing is a dynamic test suite where we would alter the conditions during the test. For example, I connected a client at NEC 65. I want to move it farther while the traffic is running. And I want to see how the AP adapts to this. That's when the dynamic test gets useful. And we use two different packages for these tests. And then, going to the next slide. And then we throw environment into this mix, right? For example, suppose I get a AP from Cisco. So this might go into a coffee shop around the corner, or this might go into a venue or a stadium somewhere, right? So will it behave the same way in both these? Definitely not, because we have different RF conditions, and we have different client mix, and we have different expectations from the clients, and also the volume of clients that are connecting to these AP would significantly differ, right? So when we wanted to test our APs, right, we were trying to get the reports from the field on how the average channel utilization looked like. So we surveyed across 1,000 plus facilities in and around Philadelphia, Chicago, and San Francisco. Based on those surveys, we have this sample report. This is only for Philadelphia. So what happened is we took an air check. We went to a venue, or we went to any facility. We ran a test, and we also saw what the channel utilization looks like. Most of the time, we don't have to. It's no more a secret, right? 2.4 is always clogged. 5 gigahertz, it's at the moment very good, but when you go to venues, these results would significantly differ. So we got these environment profiles with respect to noise, with respect to utilization, with respect to the clients into our mix. So then we classified this into two things. One is busy RF, the condition of the RF environment, and the client nature. So I want to separate this because not everything gets into the same mix. So for example, if I'm talking about busy RF conditions, I'm looking at 25 plus APs on the channel, and channel utilization in excess of 40%, higher noise floors, and high Wi-Fi utilization, and also non-Wi-Fi utilization. And when I go to a significantly lesser suburban type or even a country type environment, right, I'm looking at lesser APs on the channel, lesser channel utilization, and all that. Now, that doesn't mean that in a non-busy environment, we have the same kind of clients. For example, I deploy my AP in a mall somewhere, in a suburban area. In a mall, the kind of traffic is more volatile because people shop, people connect to random APs, and they get back. But if I deploy the same AP in a coffee shop next to that mall, right, people sit there for some time, and whatnot, they do browsing, they connect, they do streaming, they do updates, and all those things. These clients tend to be there on that environment for a longer time. So if the clients are not moving away from the AP, they demand more and more bandwidth. For example, they want to do some video, they want to chat, or they want to even play a game online, right? So now, given all these things into the mix, right, we have created a much bigger test bed. So this actually forms the crux of the next test that I'm going to talk about. So we have an AP chamber where we put our AP, we cable it, and then we have a programmable attenuation and RF signal blending. So this enables me to control the amount of communication or amount of signal going on between two different communications. So this is divided into 4 ports. The top 2 ports and the last 2 ports are having the same RF conditions. And we separate that with the amount of attenuation that we add between them. Then on the right side, the traffic generator and an analyzer. We have Ixia Wave for all the data traffic, and we have MXG spectrum generator for generating a signal with a constant duty cycle on any particular frequency. Then the interference generator that I'm talking about on top is we have another card from VeriWave which actually does just noise, nothing else. And then if you look at the Wi-Fi synthetic AP, I have a card from Ixia which allows me to simulate up to 64 APs on a single channel. So each of these APs can have independent power levels, different clients, and all that, and they can simulate it, and they can simulate any kind of communication, whether it's to a real client or to a synthetic client. So in this test bed, so this is a further explanation on what it is and how each of these elements play. So now let's talk about the test itself in general. So let's see how volatile clients affect our network, right? For example, assume that you have an AP near a train station, right? What happens? Suddenly a train comes, there are hundreds of people coming out of the station, and all of them connect to the AP, and then all of them disconnect. And then there is another plethora of users coming and connecting to this AP. So is your AP capable of handling all this? So there are 50 different clients connecting and disconnecting, and there are another 50 clients connecting immediately and disconnecting. So what happens is, we have seen that traditionally some of the APs have actually not reacted well under this kind of environment. So two different problems here. One is probably the client database in the AP itself. You want to have certain timer until when you want to retain the client in your table. If you don't, you might start with the DHCP process and all that and create an overhead on the network. So that's one thing. And secondly, if you have this timer set very high, right, you might get into a process where your buffer has overflown and resulting in memory leaks, each of which would actually create a degraded performance on this AP, right? So this is how we configured the volatile client conditions. We have different client groups, and if you see, we have probably 8 Wi-Fi client groups and 1 Ethernet. So the configuration is all these Wi-Fi clients demand bandwidth across the single outbound port, right? So that's the configuration. So we have different flow groups, right, from 1 to 2, 2 to 1, 1 to 4, whatever, right? So we start this test with just one group connecting. And then in the middle of the test, we connect another group. Then we connect another group. Then we disconnect some. So how does the AP react? So how long does this test run? Probably it's up to our choice, whether we want to run it for an hour, we want to run it for 4 hours, or we want to see when the AP actually breaks. So this is about the volatile clients. Now, this is one of my favorite tests, progressive loading. So say AP is already serving some clients, and suddenly clients keep on adding. What happens? How does the AP react? Right? So there are 2 cases here. Maybe a client has come to join the AP then and there, and it starts the communication. Or there is an AP there is a client that has already connected to the AP that has been in power save mode all the time and suddenly wakes up and starts sending traffic. So these are 2 different cases that have been presented to us because under the baselining conditions, yes, everything looked fine for 4 hours. But if the clients are adding, how does it handle was the question. So if you look at the screenshot at the bottom, you would see that we have created about 30, 40 clients, where some client starts at 0th second and continues till the end. And then there is another client that started at 30th second and continues till the end. So in this test, every client keeps on adding every 30 seconds and then runs the traffic till the end. So how does the AP handle this situation was something that we wanted to get out of this test. And yeah, we must fairly say that 60 to 70% of the APs have done well here. And yeah, whatever have failed, have failed. So now, let's get back to power reduction. So in the previous presentation, Christian was telling, yeah, we have applied power reduction because when the client sees higher RSSI and is unable to do anything, it's a mismatch of the power levels, right? So we have typically seen another case where we had a beacon overreach. For example, our beacons are seen everywhere, and the client attempts to connect to it, and it could not connect. So we termed it as beacon overreach. So what we did was reduce the management frame power by X number of dB. So what happens during that time? So as he explained, so we have seen clients trying to connect at next 70, next 75-ish, and since we had a link imbalance, AP was seeing them at neg 85, neg 90, and nothing was happening. So the client even did not get the DHCP IP, or the authentication or probe did not happen. So there was an impression that, yeah, maybe the network is there, but it's not functional. What is happening? So we wanted to get that optimized. So that's where we spec this test. So what we do here is we have to be sure on how much power we are reducing beyond, and how it affects the AP. So what we did was we baseline the AP with a regular default power level with our rate versus range test. And we see what happens here. So we have a default power level, and the client starts connecting to it at 0 dB attenuation. And then this test runs where the client backs off 1 dB each time and runs a throughput test at the specified packet size. And it goes up until it gives up, right? So this is the default. And now we reduce the transmit power, and we see how much of a difference with respect to throughput and with respect to the coverage that we have seen with this particular configuration. So that's what this test is all about. And then band steering. So client devices are predominantly trying to connect to 5 gigahertz network, while some of the APs are trying to make decisions based on the client conditions that they see when they try to associate. So we have two kinds of band steering here. One is pre-association, and the other one is post-association. Imagine you are walking towards an AP, right? Your 5 gigahertz is at a much lower RSSI, and your 2.5 is overpowering it. So you have associated to 2.4 at that particular time. But how sure are you that the 5 gigahertz weaker RSSI is performing worse than the 2.4 stronger RSSI? We never know that. So how do we get to it? So we run a baseline of RVR test on 2.4 and 5 gigahertz independently. Then we attach the client at 1 dB attenuation steps and see where it ends up, and we see whether it ended up at the right band at the right experience level. So that's the comparison that we get out of this. And then auto channel selection. So how many of you have left your Wi-Fi network on the auto channel at any of your deployments? Okay, I see a few hands. So how sure are you that the AP is doing the best auto channel selection?
0.
That's a good number. Yeah, because, because I have seen that some portion of our APs in our network are ending up on channel 5 when they are left on auto channel selection. And even if I say 1%, that's probably 17 million devices that I'm talking about. So that's a significant number, right? So the alternative that we do is, okay, we can plan channels, but given the scale of deployment that we have and the nature of environments and the variety of environments that this AP goes in, we can't always be channel planning. I mean, at Comcast, I'm talking. If you're having a unique venue case, probably, yes, you should do your channel planning and everything. But so how do we evaluate the effectiveness of auto channel selection, right? So here we have two things that we introduce into the mix. One is the channel utilization and the noise, and the number of SSIDs per the channel, of course, right? So what happens is we create utilization using the golden APs pairs. So for example, I have my AP on channel 149, right? So I introduce utilization on the same channel with the golden AP up to 64 SSIDs. So, and I re-trigger my auto channel selection on my AP. Does this AP lock to the same channel, or does this move to another channel? So if it moved, what channel did it move to? And what are the characteristics of the channel? So that's one test. Second thing is we create we create noise using signal generator on the other channel that the AP has logged to, and we see where it ends up. So now you can be creative and you can throw hundreds of tests here, but I just wanted to make sure that we touch on this point. So I'm not going into the different parameters or whatever you want out of this test, right? So co-channel and adjacent channel interference. So how many of you feel that these are among the top 5 factors to be considered when you're designing a wireless network? Wow. Only a couple? Yeah, some more hands raising. Okay. So here we have 2 things, right? The amount of interference that we see and the level of interference that we see. When I say amount, right, how much percentage? When I say level, at what threshold can I avoid this, or what can I do to do? So what we do here is for co-channel interference test, right? So we just put the golden AP just like the other auto channel selection test, and we just run it, and everything goes by. But with adjacent channel, what do we do, right? Say there are 2 ways we run this test. For example, I'm doing it on 2.4. I will introduce my AP on channel, say suppose channel 6. I put some noise on channel 1 and some noise on channel 11, so that how much degradation my AP has seen is the question here. Secondly, when I talk about 5 gigahertz, right, when I am selecting Uni 1, I have some APs and some communication and noise going on in Uni 3. So I would just see, okay, it did not make much of a difference. That's good. And what happens if I'm on channel 149 and I see utilization and noise on channel 153? And that's one condition. So what we do here is, so if you feel that your AP has degraded, so what do? We can adjust our channel, the interference avoidance thresholds, like I said. But so far, from our experiences, it has always proved detrimental, because anything we do with ANI, we always saw bad results coming back. So this is one way to benchmark an AP for CCI and ACI. So moving on to the next section. We have lived with a network, not generally Xfinity, but we have seen one of the access points that when you have multiple SSIDs configured and when you have clients connected to all these SSIDs, right, the results are everywhere. For example, I connected clients to 2 different SSIDs to the same AP. I started running ping to the DNS server. The client 1 gets the responses back, and the client 2 doesn't. And it swings. The client 2 gets the response back, and the client 1 doesn't. So initially, we thought maybe it's creating some kind of a congestion among itself. But we have seen that in one network element configuration, we are seeing good results, and in the other, we are not. Then we started diagnosing, could it be a network problem? Then they said, no, it's not a network problem, because all the other APs are working fine. Then we have gone back to see the logs on what the AP is doing. So we have seen that the AP, under some special conditions, is only transmitting 1 frame over the Ethernet than the other. So it happens to be like 15 seconds, SSID 1 doesn't get any response back from the DNS server. And next 15 seconds, the client 2 doesn't get any response. So that's the reason why we have a benchmark test wherein, okay, you are deploying 5 to 6 SSIDs on your AP. So let's connect a client to each of these. Let's just do 3 things. Ping, then run a throughput test, then run a video stream parallelly across all these clients. So far, we have seen a good positive response, because we have identified some issues. We got them resolved, and everything is looking good from this perspective now. Now, the probably last test in our suite is roaming. So roaming is essentially one of the most important feature that is defining the way our network is actually going to be in the future, right? For example, you deploy 500 APs. Why do we deploy 500 APs? To make sure that the client takes the advantage of best AP and the best conditions that it is presented with, right? So if the client becomes sticky and if the client doesn't roam, all this design would not be effective, right? So that's the reason why we have a test for doing all this kind of roaming. So what does this do? So how many roams can my network handle per second? When I say network, it could be just 2 APs, or it could be a multitude of APs that I have deployed. And during this roam, how much packet loss do I tolerate? And how much delay can I afford during this roaming, right? So all these are characteristics that we use, and the report would actually give the number of roams that have happened, number of roams that have actually passed everything, number of roams that failed this category. And now to create more interesting scenario for this, we introduced the utilization and noise to the mix. And then we also said, OK, synthetic clients do very good. Now let's see what happens with the real clients. Because we have seen operation system behavioral differences when we try to roam an Android and when we try to roam an iOS. So within Comcast, we have said, OK, we see a multitude of deployments. So let's invest in every possible tool and every possible device for us to be able to test our APs. But one question that comes to mind, so how much do I invest in the test gear, and what kind of test gear should I get, and what kind of test should I run? So there are 3 factors, right? Whether we want to run the test over the air, whether we want to run the test cable. For example, just take a dual 5 gigahertz radio AP. So what happens if you run a cable test? Everything looks absolutely perfect because you're not creating any interference, you're not creating any conditions where one radio starts impacting the other. But if the radios have a poor separation, if you run this test over the air, one radio or both the radios are degraded. So I would recommend over-the-air tests for most cases, unless we are looking at any benchmark. And for the test where we need benchmarking, what is the max throughput, what is the latency and all, I would recommend a combination of both over-the-air and wired tests. Secondly, so when you are performing this test over the air, so what kind of an environment do you perform with? Do you need a chamber? Maybe. If you need a chamber, what kind of a chamber do you need? Do you want to go for an isolation chamber or a reverberation chamber? While isolation chamber is good, it would not help you with the multipath. And the results obtained from the test might significantly differ from what we see in the real world. So for any of the tests that are involving this kind of multipath scenarios, I would always go for a reverb chamber. And also, the chamber should be large enough. Otherwise, you would see very bad results. Because, for example, we had a Lindgren chamber, a reverb chamber that was probably 2 by 2. And we have a bigger chamber that's 8 by 8 at some other facility. The results obtained with the same test device, with the same client, actually differed by 75%. I would guarantee that. So that's more important. Then we have already talked through whether we are going to baseline with a real or a synthetic client, because wherever we are saying that operating system might create a lot of difference, we would always have to do the test with actual client. The synthetic clients only help us when we want to test things at scale. For example, if I want to test something with 500 connected clients, it's near to impossible for me to get all those 500 clients to run a test, right? And also the facility to run this. So in those cases, probably synthetic would help, but any functional behavior, I would always use my real clients. And when I say real clients, we always go with the top 5 popular clients in the market and top 5 clients connecting to the network. And this is our lab. So we have gear predominantly from Ixia VeriWave. We have Wave 2, Wave 1 blades. We are capable of getting a layer 1 results like EVM, spectrograph, whatever. Then we also have interference generation cards. We have RFMU, which is a programmable attenuator, which allows up to 90 dB of attenuation. Then for getting the environment baselines, we use NetScout. And in some cases where we need to see what kind of packets we are simulating and generating, we go to the field, we get the packet captures back using OmniPeak and all these things. So that's our lab. Yeah, and this is our spread. We have APs that go into people's homes. We have APs that go into small, medium businesses. We have outdoor APs where we have hung up APs around traffic signals. We have them everywhere, basically. And then we have different set of APs catering to stadiums. And we have different, for example, even Universal Orlando is Xfinity WiFi. And then, last but not least, the train stations. And now we have partnered with some of the stores. For example, if you go to a Wawa outlet, you would see Xfinity Wi-Fi is here. So that's the latest thing that we went into. So we have 20 to 25 models of APs that are deployed across the network, and we also and our vendors include all these: Cisco, Technicolor, Ruckus, Meraki, Aris, Ericsson, Ubiquiti, and Aerohive. And so we cater to different kinds of things, like a customer's private Wi-Fi to a public Wi-Fi to home security and IoT and all these things. So that's what we kind of already discussed this, what kind of gear suits you, what kind of gear should be bought. So even though we are using Ixia VeriWave, a very high expensive gear, I repeat some of these tests using a very inexpensive gear at my home, which might be like a Raspberry Pi with an adapter trying to build an ad hoc network so that I can create utilization on a particular channel, right? So, and there have been people who have already talked about how to make sure that your test setup is effective yet inexpensive. So if you have any further questions, yeah, I can take a few questions now. If you have further questions, feel free to contact me. That's my email. And finally, I thank Tom for the opportunity to present here. And there have been so many people that have actually helped me get to this level with my presentation. So thank you.
Thank you. Any questions? Yes, sir.
So Ravi, you opened up with you identified some unrealistic marketing expectations. You balanced that with reality from the lab and your field testing. You also identified, I think it was like 6 different verticals that you guys focus on. For those 6 verticals, which one has been most challenging to balance those expectations?
So the question is, we started with what are unrealistic expectations that we have today and how we are testing and what are the realistic challenges that we have. And question is, which is the most challenging thing that you have seen? So we have this outdoor space. When I say outdoor space, the APs get to every possible corner, right? So the amount of scenarios that this AP sees is far higher than any other thing, because if I get any AP, for example, a Resi AP, I know it's going into a customer home. But with outdoor, I don't know where it is going to be. It could be a street light, it could be a street pole, or it could be near a station, or it could be in a park somewhere. And it could see clients connecting from far, from near, whatever. So that has been the most challenging of the environments that I've seen.
Yes, there's a question there.
Ravi, you talked a lot about how you did testing in your AP chamber and stuff like that, specifically for client performance. Have you done similar testing of the same clients in real-world scenarios to see what the performance variations are in an isolated chamber versus a real-world scenario deployment?
Yes, definitely. So we have this approach, right? First specify, then test, then confirm. So we specify the test. When we go into the testing phase, we test it in an isolation chamber. Then when it comes to confirmation, right, we go into a real world and we test.
And what are the performance differences that you typically see, if any?
So typically, since we have based our tests on the environments that we see, so I would say probably about 10% to 15% margin here and there, but otherwise we are close.
Yes, sir.
Sorry. Could not get it properly. I might have to get close.
Can you give him a mic or something? Or I can?
Hi. Are you doing some TIS and TRP measurements for the cable modem?
So far we have not gone to that level yet. Yes, that's a test that we have in our plan. So I could have put some of these tests that we are speccing at the moment, but I wanted to see the results before I talk about. So yes, that's in the plan, and so far we are not doing.
We have 28 more seconds, so. Yes, sir.
Why is it that the Comcast business class modems, Wi-Fi is enabled whether you use it or not? It just seems like it's a default setting. Is there any thought to disable that with environments where it's not planned?
So there are so many things.
Can you repeat the question?
I heard it, so let me confirm if this is the right question. So the Comcast small and medium business access points, right, that you have talked about, and why are they deployed with the defaults, right? So we are talking about a lot of changes that need, so we have built devices with our legacy platform so far. So we have a set of feature requests that we have already put to the vendor, and some of these changes are starting to come, and then these are going to change.
I mean, now that we have the guy here, I'm tempted to go slightly over if you're okay. It's only lunch, right? Who cares? Any other questions?
Yeah, just a really quick one. So, in your opinion, 8x8 or dual 4x4 5 tri-band for your testing, which is better?
4x4 tri-band?
Yeah, like dual 4x4 5 tri-band, like this 2.4 or 8x8 5 gig.
So what was the question? If you have a dual 5x4, dual 4x4 5 gig and a 2.4.
Yeah, and 1 AP, or would you rather have 2.4 with an 8x8 5 gig?
So far, even though we are saying 8x8, the only device we have seen is probably one device so far. And it cannot do a 160 megahertz, so there is only one chipset so far in the market that came to our lab, right? So I would always recommend a dual 4x4 5 gig ahead of an 8x8 from my testing experience, because I might have seen a very bad copy of an 8x8 chipset, but that's what I would stick to at this point.
One last question. So was this all consumer gear, or you've done consumer, enterprise, everything?
Everything.
So without naming names necessarily, but how well does price, for example, and reputation, well, let's say, how well does price correlate with AP performance?
It correlates fairly well, but within Comcast, right, for our consumer gear, we always take the specs and we invite proposals for the vendor, because based on the number of deployments that happen, we always see the economies of scale, right? So far they are doing good, but in a retail consumer space, definitely. So if I bring a consumer retail router and put it with a enterprise grade Cisco or Ruckus or whatever, right? The performance would significantly differ.
And within enterprise grade gear, how much differences are you seeing, for example, between the different high-end brands, without necessarily, blaming or praising?
So within the, say, I just take one vendor. I do not even compare vendors at this point. So that vendor makes very good gear, but we have seen some APs are not at all good. Some APs are real good, right? So the price kinds of works for itself.
Okay.
Not saying that tomorrow you have to give me a $2,000 AP.
All right, we're 4 minutes over. Thank you for the outstanding presentation.
Thank you.
Again.
Thanks for the nice introduction, and thanks for the opportunity, guys.